Constraint layout chains. Constraint layout chains provide a way for the layout behavior of the two or more widgets to be defined as a group. Chains can be collected in either vertical or horizontal axis and configured to define how the widgets in the chain are spaced and sized. So widgets are chained when connected together by bidirectional constraints. For example, let's actually create the example chain here. So we're gonna add 3 buttons in here, 1, 2, and 3. Make it a line like this, and here. So now we're gonna constrain it here. The button 2 to button 1, button 3 to button 2, and here we will right click on them, and here click on the chains here, chains, and here create a horizontal chain. And as you can see here, this is our example application for the chain. So the first element in our chain is a chain head, which translates to the top widget in a vertical chain, or in the case of horizontal chain, the leftmost widget. So in this case, this is the chain here. So the layout behavior of the entire chain is primarily configured by setting the attributes on the chain head widget. So we have several chain styles here, which is the layout behavior of the constraint layout chain is dictated by the chain style setting applied to the chain head widget. So the constraint layout class currently supports the 5 chain styles, which is spread chain, spread inside chain, weighted chain, and packed chain. So it was 4. It's 4. So the spread chain, the widgets contained within the chain are distributed evenly across the available space, and this is the default behavior. This is the default behavior for the chains. So the spread chain here, and we also have the spread inside chain. So the spread inside chain is contained with the chain are spread evenly between the chain head and the last widget in the chain, and the last widget are not included in the distribution of spacing here. So we can also make this like this here. We can delete the margins of it here. Chains, chain style here. We're gonna change spread inside chain, and as you can see in this case, this is the spread inside chain. Spread inside chain, and we also have the weighted chain here. So weighted chain allows the space taken up by each widget in the chain to be defined via weighting properties. So we have in order to create a weighted chain, we will also do all examples with the chains in next lectures here. This is just we can also create a packet chain, weighted chain, but in next lecture we're going to create the weighted chain here. We also have the packet chain. The packet chain, the widgets that make up the chain are packet together without any spacing. A bias may be applied to control the horizontal vertical positioning of the chain in relation to the parent container. So we can create a chain with this packet chain here, and this is our packet chain in Android layout editor and in the constraint layout. So this was the chains here. We will do all examples in next lecture. This is just an introductory and fundamental lecture for understanding chain and different view styles and constraints in constraint layout. And now we're gonna learn about the constraint alignments. First, let's check the lecture time. Yeah, it's 4 minutes already. Yeah, the baseline alignment here. So far in this lecture, we have only referred to constraints that dictate alignment relative to the sides of a widget, and typically referred as a side constraints like this. This is the side constraints. So a common requirement, however, is for a widget to be aligned relative to the content that it displays rather than the boundaries of a widget itself. And to address this need, constraint layout provides a baseline alignment support for us. So as an example, assume that the previous theoretical layout for this, the text view widget to be positioned 40 dp to the left of the button, and in this case, the text view here, we have a text view. The text view here needs to be baseline alignment with the button view. So and this means that the next button needs to be vertically aligned with the text view within the text view. So here we're gonna create a baseline alignment. Search for the baseline. Oops. Good line alignment, and here we're gonna create a horizontal constraint for it. First, this is the text view, and this is our previously created button here. And here we're gonna delete this constraint of button and make this here. Delete. Also we will delete this. And here the button is gonna be right here. Delete the bottom constraint here. Make it right here. And here we will also make it the baseline alignment here. So this is the baseline alignment here, and the text view is now aligned vertically along the baseline of the button and positioned after 40 dp horizontal here. We can, if we delete this here, we will delete this and align this to bottom of the text view, and we will make it like this, and the text view is now aligned exactly where the button is. And we will also use the GUID helper, and we can also configure the widget dimensions here. So controlling the dimension of widget is a key element for the user interface design process. So the constraint layout provides 3 options which can be set on individual widgets to manage size and behavior. So these settings are configured individually for height and width dimensions. So we have fixed fixed match constraints and wrap content. The fixed here, the weight is fixed to specific dimensions as name implies. We have match constraints. This allows the widget to be resized by the layout engine to satisfy the prevailing constraints. And we also have the wrap content, which is the wrap content. The size of the widget is dictated by the content it contains, for example, text or graphics. In this case, we will also use the wrap content in next lectures, and we also used the wrap content in previous lectures for when we created the navigation application in our course. We also have the GUID line helper. So in order to use GUID line helper, you need to call GUID line helper. Vertical, we have 2 kinds of GUID line helper, horizontal and vertical. So GUID lines are special elements available with the constraint layout that provide an additional target to which constraints may be connected. So multiple GUID lines may be added to constraint layout instance, which may in turn be configured in horizontal or vertical orientations. So once added, the constraints connections may be established from widgets in the layout to GUID lines. So this is particularly useful when multiple widgets need to be aligned along the axis. For example, we can also create a GUID line for the 3 buttons in here. We will implement new 3 buttons here. So for example, this is our GUID line here. We will add 3 buttons side by side, 1, 2, and 3. And here 1, 2, and 3. And this is the GUID line here. 1, oops, yes, 1, 2, and 3. Make the top constraints here. 1, 2, and 3. Here like this. This is the GUID line helper. And this is particularly useful when multiple widgets need to be aligned along an axis like this here. So in this example, the 3 button objects contained with the constraint layout are constrained along with the vertical GUID. You can also make this vertical GUID like that. Oops, we have not implemented the vertical GUID here. So you can also make the vertical GUID like that, make it play with it, make it a bit lefter or a bit righter like this here. We also have the group helper and barrier helper, which we will discuss and create an application with it in next lectures. So I'm waiting you in next lecture.